Now, this is a very simple topic that we are discussing today, and that has to do with the various kinds of rules we use to determine how compounds would be formed. Right? I mean, how would the elements combine to form compounds? And those are the duplet, octet, and 18 electron rule. And the rule essentially, these rules essentially tell us how many electrons a particular atom would try to have so that it becomes stable. So the origin of these rules is actually very simple. Instead of learning so many rules like duplet, octet, 18, these rules, we can understand all of these rules from our basic periodic table. So here is the periodic table. This is something that we should actually by heart, which you just learned. And there are several classes that I have taken on DoostepTutor, our channel, dealing with this periodic table, and more detailed classes are available on the website for NEET as well as for JEE. So the idea here is that the periodic table, the way it fills is that first the 1s electrons, those 1s shell, that particular shell and that particular subshell. So 1s is a shell, 1 is a shell, and it has only one subshell, which is the s. So that particular subshell in the first orbital gets filled, and from here we have the duplet rule. So what does the duplet rule tells us? It tells us that in that first period of the periodic table, that first row, what would happen? The elements in that row would try to gain 2 electrons, would try to have 2 electrons, not really gain, but would try to have 2 electrons in their 1s subshell and try to become helium so that they are stable. So 1s2, that helium configuration, is the stable configuration for that first period. What about the octet rule? Now, octet rule is something which is very common, and that is what is typically asked in the exam. So for octet rule, we go on to the second and the third period of the periodic table. Right? So again, periodic table, periods, and what are the groups and what are the blocks of the periodic table, those things are again very important, and those things we have covered in separate classes, but here we are just using that knowledge. So the thing is, the second and third period of the periodic table, we go there, and the elements in this periodic, these two periods follow the octet rule, which means that they try to have 8 electrons. And why do they try to have 8 electrons? Because if they have 8 electrons, they become, if they are from the second period, then they become neon, which is again very stable. And if they are from the third period, then they become argon, and of course argon is also very stable. So that is why for these two rows, the octet rule is followed. Okay, and we'll see examples of how the octet rule and the duplet rule, they are followed. Okay, and then lesser used rule is actually the 18 electron rule. Now the 18 electron rule holds for the next two periods, which is 4 and 5, and in this case we have to fill both the s orbital. For example, this 4s1, this s orbital has to be filled, and then the d orbitals, all of them have to be filled. Okay, the d subshell complete has to be filled, and then the p subshell has to be filled. So that comes out to be total of 10 in d, 6 in p, 2 in s. So there are total of 18 electrons that these elements in these two in these two periods would try to have, and that is, they will try to become a krypton or xenon, and that is their most stable configuration. Okay, so that is where this duplet rule, octet rule, and the 18 electron rule, that is where it comes from. Now let us see examples of simple compounds where this rule is being followed. So hydrogen is the only example of the duplet rule. And in the duplet rule, in the case of hydrogen, what happens is that two hydrogen atoms, they come together to form the hydrogen molecule. Now hydrogen molecule, it has 2 electrons. The 2 electrons are available to both the atoms. So that means that each of them has shared their 1 electron, and now in their sharing configuration, once they have this covalent bond, the sharing configuration, in this sharing configuration, it looks like to each of these atoms that each of them have 2 electrons, whereas of course one is their own, the second has come from the other atom. But for their purposes, for all intents and purposes, their S subshell is now completely filled, and the duplet rule is being obeyed when the two hydrogen atoms, they combine together to form a hydrogen molecule. Now what about octet rule? Now in the case of octet rule, let's take example of carbon dioxide. There are other examples as well. For example, water. The oxygen in water follows the octet rule, whereas the hydrogen in water follows the duplet rule. Okay, but let's take an example of carbon dioxide, because here everyone, all the concerned atoms, the carbon, both the oxygens, they each have 8 electrons. They try to gain our electrons from the other person, or share electrons from the other person, other atoms, in such a way that each of them have a total of 8 electrons. And that is why we say here that the octet means, octa means 8. So here we say that the octet rule is being obeyed. So carbon essentially gets 2 electrons from oxygen, and therefore it has these 3 electrons are from the oxygen, and these 2 electrons are from the other oxygen, and there are 8 electrons around carbon now. So how many? 4 here, total of 8 electrons. Similarly, the oxygen, it is getting these 2 electrons from the carbon, and therefore what does it have? It has a total of 6 of its own. 2 it gets from the carbon, so total of 8 electrons. So the electrons are again shared in such a way that each of these atoms feels like it has 8 electrons, although some of those electrons are its own electrons, others have come from the nearby, the adjacent, the element to which it is bonding, the atom to which it is bonding. But essentially the octet rule is being obeyed for each of these cases. So now that we have understood the octet rule, here is what the summary is, and these rules are again very important. Sometimes questions are being asked. They will just ask you what is the octet rule, which elements obey it, and they will just show you a compound and ask you that what kind of rule is being obeyed. Numerous questions can be found, but this is for our understanding, and all of these rules, as I have shown, can be derived from our basic periodic table. Very important. The periodic table, look at all the classes that I have taken, all of them are very important. The terminology and the how the periodic table gets filled, those things are important. Thank you.